Morning, everybody. Okay, so yesterday we talked about how to divide polynomials using long division. Today we're going to talk about how to divide polynomials using synthetic division. And we're going to talk about when you use one versus the other and what the benefits are to each. Okay, synthetic division in general is quicker and easier, but unfortunately there's only specific times you can use it. Okay, so I thought we'd actually start by going through one of your homework problems. So I'm just going to grab one of these and go through it. It doesn't matter which one. Let's see. We'll do from that page. Okay, let's go through number 4. Not number 4. Let's go through number 3. Okay, if I were doing number 3, I would write out 3x to the third plus 11x squared plus 4x plus 1. And then I want to divide all of this. Wait, I room. I'm going to divide all of that by x squared plus x. Okay, now check your exponents. I have to the third, to the second, to the first, and to the constant, so I know that's good. Alright, if I put an x here and multiply by x squared, I would get x to the third. So then the only thing I need to do is put a 3 here, and then I get 3, oops, sorry, don't do that. If I put an x here, I'd have to raise it to the third. Times x squared would make it x to the fifth, so that's not good. I kind of just showed you where to put it, so we need to put it over the x and make it 3x. 3x times x squared gives me 3x to the third. 3x times x is plus 3x squared. Remember, I want to take this whole thing and I want to subtract. Make sure to throw it in parentheses. My first terms cancel, so that's good. 11x squared minus 3x squared is 8x squared. I bring down my positive 4x. And then in order to get an 8x squared, I just need to have an 8 here, which gives me 8x squared plus 8x. Show that I'm subtracting this whole thing. First terms cancel, that's good. 4x minus 8x is negative 4x. And then I bring down my 1. And I have plus 1. I have nowhere else to go, so that whole thing then is my remainder. So my answer would be 3x plus 8 plus negative 4x plus 1 over x squared plus x. Okay? Alright, now that you've seen that, the warm-up is to find the quotient of these two polynomials using long division. So why don't you pause this, try to do that, make sure you can do yesterday's skill before I teach you a new skill. Okay? Pause it, try on your own. Okay, so let's see how you did. I cannot start by putting anything over the x cubed. I can start by putting something over the x squared, and I just need to get x cubed, so I just need an x squared. X squared times x gives me x to the third minus 7x squared. Okay, I want to subtract this whole thing. Show your parentheses. First terms cancel, that's good. A negative 7 is a positive, so I have negative 13x squared and a positive 7x squared. So that gives me a negative 6x squared. Okay, I bring down my positive 40x. I need to multiply to get a negative 6x squared, so I'm going to throw a minus 6x up here. When I multiply, I get negative 6x squared plus 42x. And then remember, I want to subtract this whole thing. First terms cancel, that's good. 40 minus 42 gives me negative 2x. Bring down my positive 18. And then I need a negative 2 here, which gives me negative 2x plus 14. Subtract. I get 18 minus 14 is 4. So that's my remainder. So my answer is x squared minus 6x minus 2 plus 4 over x minus 7. Okay, be careful. I feel like that most of the mistakes are going to come from you multiplying and forgetting like a negative times a negative is a positive, or just not paying attention to that. Or the big thing that subtracting here means you have to subtract each term, and we accidentally do like 40 plus 42 and get a big 82. Okay, so just be careful as you work through those. So let's move on to today's material then. So now synthetic division. We can take what we just did, so the exact same polynomial that we just had, and we can actually solve it and get the exact same answer using synthetic division. Okay, so here's how we set this up. We talked a little bit yesterday about the fact that if we're dividing by x minus 7, that means that x equals 7. We can consider, we don't necessarily know if it's a solution yet unless we have that remainder of 0, which we got yesterday, but we at least know that because we're dividing by x minus 7, that this is a 0. Okay? So, whatever my 0 is, or in terms of what I'm dividing by, I write a 7 here. Okay, this number right here will always be the 0. So always be 0. It's coming from x minus 7 equals 0, so x equals 7. Okay, the numbers next to your 7 are just your coefficients. So x to the third has a coefficient of 1. Your next coefficient is negative 13. Your next coefficient is 40. Your next coefficient is 18. Space them out a little bit. Okay? All of those numbers, so I'm going to make a note here, are the coefficients of your terms. Okay? And then we also want to make note here, we need to remember placeholders if missing any terms. So just like yesterday we had to have a placeholder, today we do too. Okay, so here's what we do. This number will always be brought down, so 1. After you have a number under this line, you always multiply it by this number up here. So 7 times 1 gives me 7. And then I always add these. So negative 13 plus 7 is negative 6. And I start back over. 7 times negative 6 is negative 40. And then I add these. 40 plus negative 42 is negative 2. And then I start over again. 7 times negative 2 is negative 14. And then I add. 18 plus negative 14 is 4. Okay? And now look at what you have right here. I have a 1, that's my x squared. I have a negative 6, that's my negative 6x. I have a negative 2, that's my constant. Whatever you are left with right here, that's always your remainder, which is my remainder that I got up above, too. Okay, so because I'm dividing by a linear term, so because I'm taking x to the third in this whole polynomial and I'm dividing it by x, that means I'm losing one of my powers. So instead of x to the third, it's x squared. That's how I know that this 1 right here represents the next term down, x squared. And then I just follow an order that the next term would be minus 6x minus 2 plus 4 over x minus 7. And I just got the exact same answers up above, and it is way easier than doing long division. Okay? So right now you're probably like, oh my god, I want to do synthetic division all the time, but the question is when? When do we use synthetic division versus long division? Well, we use synthetic division when we were dividing by a linear, like we just did, that was x minus 7, or we know a 0. Because synthetic division, you have to know a 0. That's what goes in that box right there. Okay? So let's try it again. Alright, so each time we start a problem, we want to make sure that we're looking for a linear, or we tell you that your solution is like x plus, or x equals 3, or x equals negative 8, something like that. Okay? In this one, we're dividing by a linear, so we can use synthetic division. So we want to start by first saying that x plus 4 means that I'm going to have a negative 4 in this box. If I were to solve, it would be negative 4. I look at my coefficients. I have a 1, I have an 8, I have a 1. Draw my line. Really bad line, sorry. I draw my line. Bring down my 1. Multiply. Negative 4 times 1 is negative 4. I add these. 8 plus negative 4 is 4. I multiply. Negative 4 times 4 is negative 16. I add, and I get negative 15. Okay, now, again, notice that I divided x squared by x, so that means I lose one of those powers. Okay, so whatever your leading term is, when you do synthetic division, you will always have the next power. So since it was x squared, then the next power down would be x. So that means that this is an x, or 1x, plus 4, and then minus 15 over x plus 4. Way quicker. Okay, let's try another one. Alright, my solution would be negative 2. My coefficients, now we got to be careful because it goes 4, 3, 1 constant, so remember I need placeholders. So my first coefficient is 1, and then 11, and then I don't have an x squared, so 0, and then negative 16, and then negative 4. Okay, I draw my line. First, I bring down my 1. I multiply. Negative 2 times 1 is negative 2. I add. I get 9. I multiply. I get negative 18. I add. I get negative 18. I multiply. I get 36. I add, which gives me 20. I multiply, which gives me negative 40. I add, and I get negative 80. Alright, so I know that I started with an x to the 4th, so that means that 1 is x to the 3rd, plus 9x squared minus 18x plus 20, and then this, sorry, I should be circling these, those are always my remainders. Okay, so that means that I have minus 80 over x plus 2. Alright, flip it over. Alright, we'll try 2 more, and then I'll let you guys try some on your own. You can pause if you want and try it on your own. Alright, so I'm dividing by x plus 4, so I can use long division, or sorry, I can use synthetic division. Do negative 4. My coefficient, my powers are 3, 2, 1 constant, so that's good. So I have a 3, I have a 16, I have an 18, I have an 8 on my line. Okay, first thing, bring down my 3 and multiply. I get negative 12. I add, I get 4. Start it over, I multiply, negative 16. I add, I get 2. Multiply, negative 8. And I get 0. Okay, this means that my remainder is 0. So, 1 down, 1 term down from x cubed means I have 3x squared plus 4x plus 2. Okay, we're going to talk more tomorrow about what that means that I'm getting a 0 in synthetic division and how that means I just took a cubic function and moved it to a quadratic function, and now I know that x plus 4 is a solution. I can now try to factor what's left and find my other solutions. Okay. Alright, next one. I'm dividing by x plus 3, so I know that that gives me a negative 3. Alright, look at your coefficients. The first one is 1, but I don't have an x squared, so it's 0. I have an x, and then I have a 6. So 3, 2, 1, 0. Okay, make sure you're always checking. Start by bringing down my 1, multiply, add, multiply again, I get 9, add, I get 5, multiply again, I get negative 15, add, I get negative 9. Okay, again, we're dividing by an x from x cubed, so 1 term down means that that 1 is a 1x squared, minus 3x plus 5, and this, what is left here is always my remainder, so minus 9 divided by x plus 3. Okay? Meaning that negative 3 was actually not a solution. Okay, so some for you to try on your own. So why don't you pause this, see if you can do these. They won't take you very long. And then check your answers as I go through and explain them. I'll try to explain them a little bit quicker. But yeah, see how you guys are doing. Just make sure you're paying attention. If you're dividing by a linear, you know what that solution is, so you can use synthetic division. If you're not dividing by a linear, you have to use long division. Okay? All right, so go ahead and pause. Okay, so let's go through and check your answers. If this is x minus 5, then that means I can put a 5 here, a 2 here, a negative 7 here, and a 10 here. Alright, I bring down my 2, multiply, add, multiply, add. I started with an x squared, which means that this is just 2x, plus 3. This is my remainder, so plus 25 over x minus 5. Alright, let's try another one. Alright, I know that my solution is 3. X squared means I have a 1, I have a 0, and I have a 9. Check and see if you have that 0. Alright, I bring down my 1 and multiply. I add and multiply. I add this. So x squared means my next term down is just x plus 3. This is my remainder. So plus 18 over x minus 3. So hopefully you're starting to see that really we're doing the same thing as long division. We're just not dealing with the x's and the x squareds and the x cubes. We're just using their coefficients as a shortcut to what we're doing. We're still getting the same answer because at the end the coefficients are what's telling us what to add and what to subtract. Okay? The problem is if we get to a problem like number 8, we don't know what one of those solutions are. In terms of a linear, like we can't say it's like 3 or 5 or 8. We'd have to solve that, and then it gets messy. So in this case, we're going to use long division. Okay, so hopefully, well, you notice that hopefully there's no missing terms. So we're going to have 3x to the 4th plus 9x to the 3rd minus 5x squared minus 6x plus 2. We're going to divide this by 3x squared minus 2. Okay, so I can't start over the x to the 4th. That would give me an x to the 6th. I can't start over x to the 3rd. Times x squared would give me x to the 5th. I can't start over x squared. I can't even start over, oh, sorry. I can start over x squared because I'm trying to multiply by x squared. So I need to, this was actually a little bit different than yesterday because we never had a 3 here. So if I want to multiply, let's say I put an x squared here. Notice that x squared times 3x squared is what gives me 3x to the 4th. Yesterday we never had that 3 there, so it was a little bit easier. X squared minus 2. Now that means that I have negative 2x squared, which means I'm right over here. So I would add in a 0x to the 3rd as a placeholder. Remember, we have to line those like terms up. Okay, I'm going to take all of this and subtract. First terms cancel, good. 9 minus 0 is just 9x to the 3rd. The negative makes the 2 a positive. So negative 5 and positive 2 makes negative 3x squared. Bring down my minus 6x. Okay, and again, now we got to account for the, I need a 9. And before I just put a 9 up here. But if I put a 9 times 3, I'm going to get 27. So I actually just need a 3x. 3x times 3x squared is what gives me 9x to the 3rd. I have, my next term would be negative 6x, which goes all the way over here. So I would add in a 0x squared as a placeholder. Okay, all of this I am subtracting. First terms cancel, so good. Negative 3 minus 0 is just negative 3x squared. Don't forget your negative. Negative 6x minus a negative 6x. So those end up canceling and giving me 0x. Again, I would write 0 just as a placeholder. Bring down my 2. Okay. Again, yesterday, if that was a 3, I just went up and put a 3. In this case, though, I don't need a 3. I need a 1, negative 1. Negative 1 times 3x squared is what gives me negative 3x squared. And then negative 1 times negative 2 is what gives me 2, which gives me a 0x here. I want to, that's a positive 2. I want to subtract all of these. So my first terms cancel, that's good. 0 minus 0 is 0. 2 minus 2 is nothing. So I end up with a remainder of 0, which means that I could have solved this, found a solution that is a factor of that larger polynomial. So my answer is x squared plus 3x minus 1. Okay, so what we're going to do with synthetic division and long division is try to take it one step further to eventually factor something like we started with, where we have 5 terms. And if we can figure out one of the answers, we know that this is an answer, we can hopefully then get to this part and factor this. This is not factorable, but we'll start to look at those. Okay? All right, last one. X plus 1. So yes, I can use synthetic division. My coefficients are 3, negative 2, negative 7, and 6. I just want to check real quick. This is to the third, to the second, to the first, to my constant, so I'm good. All right, bring my 3 down. Multiply, I get negative 3. Add them up, I get negative 5. Multiply, I get 5. Add, I get negative 2. Multiply, I get 2. Add, I get 8. Alright, I started with x to the third, so this means one term down is 3x squared minus 5x minus 2. Sorry, I should be circling this. And then that is my remainder of 8 over x plus 1. Alright, so you now have 2 ways that you can divide polynomials. Okay, look to see before you start if you're dividing by a linear versus a quadratic, where we'd have to use long division. Okay, I would assume most of you guys are going to choose synthetic over long division, but they both end up giving you the same answer. Okay, there's a mixture in your homework tonight, so your homework is number 9 worksheet. In a second, you're going to get up and show the sub that you finished the notes so that you can get the homework. Okay, here's your homework. There are 1, 2, 3, 4, 5. There are 6 problems that you're going back and forth between choosing synthetic division versus long division. So just make sure you're paying attention to the question before you start. Okay, and then you have a couple word problems. Make sure that you read all of the directions and you're actually answering the question. Okay, and then the answer. Oops, sorry, the answers are not here. Factor completely. So a little extra practice with that, and look for GCFs. And then a problem where you have to identify the key features and draw a sketch. So make sure that you're factoring so that you can find zeros and draw a sketch. Okay? When you guys grab the notes, make sure that you put your Chromebooks away, put your headphones away, no music, no Chromebooks and all that stuff, okay? All right, if you have any questions, I'll be in Wednesday morning. Good luck with all this stuff.